Okay, so in this video we're going to adapt the algorithm we made in the first video into a function. And it's pretty simple. We have all the hard parts done. We just need to focus on what it means to build a function and kind of what outputs are, what arguments are, all that good stuff. So what I have here is just the code from the first video, except for this, but ignore that for now. So the way we build a function, it always starts with function, and it turns blue. It's a key word. And then we specify our outputs. So in this case, we want to return the value of our series approximation. So I'm just going to say value, and then equals, and next comes the name of our function. So my approximation. And then you have your inputs in here. In this case, we want two inputs. We want the value, so the function we're going to use is exponential of x, but we're going to have to specify our x. So x, and then we'll have another argument, which is our threshold, or the degree of accuracy that we want our approximation to be. So threshold, so we have our two arguments. And I'm actually going to put this in brackets. If you only have one output, it's not a big deal to have these brackets. You really don't need them, but for later on, I'm going to use an example where we have two or three outputs. So from here, we're ready to write our function. And whenever you do write a function, you have to have an end at the end of your function. Otherwise, anything outside of this, for one, it's just not going to run. So like if you had x equals 10, that's not going to be evaluated whenever you call your function. Yeah, I mean, it could even make the function not work right. I'm not sure. I haven't done all that. But I'm just going to copy and paste all this. And here we have that. So, should be indented. Let's see. So, as we said, we're going to specify, we have our x specified up here actually, so we can just delete this line right here. And now, whatever we have in our x is going to be our function. So, for example, if you put x equals 4, you'll have your target equation equal to exponential of 4. And usually, so I'm going to go back over to here. So ultimately, what it's going to look like when we call our function, we'll have like my approximation. And then, so we said 4, so like I'll just say 4.00. And then, as you can see here, it's our threshold, which was 1 e to the minus 6 beforehand. But we want it to be, so we don't necessarily want our users of this function to have to specify a threshold. Normally we can just say we want it to be 1 times 10 to the minus 6. So the way that we'll do that in code is by using a function called nargen. So if nargen is less than 2, so the number of arguments, as you can see, 1, 2, if they don't have 2 arguments, that means they've only specified the number that they want to be in your exponential. So if nargen less than 2, just go ahead and define the threshold as 1 times 10 to the minus 6. And so yeah, that should cover if they only have one input. And so now we can continue on. So as before, everything should run just the same. But now, as you can see, our output is value. But we don't specify what we should do with this value anywhere in this code. But we know the value should just be equal to this series sum. So we can say value equals series sum. And let's just test, series sum. And let's just test that out over here. So I'll run that and bring up my command window. And you can see it output 54. So that's the value of our approximation. So let's see what exponential of 4 is. It's pretty close. Yeah, so that's how you do that. I mean, it's pretty simple. You can also store this in a variable. So let's say exp of 4 equals my approximation. And now you can see that this result is stored in exponential of 4. So now that's it for this video. I'll make another one on how to include multiple outputs. I just want to keep these short. So yeah, stay tuned.